So for problem 40, the question is, the coefficient of static friction between hard rubber and normal street pavement is 0.8. On how steep a hill can you leave a car parked? So the first thing you need to do is draw your three body diagrams and the diagram for your angles. So what you do is, as you can see, there's the car on an incline and it's not going to be moving, so your acceleration is going to be 0. So when you draw a free body diagram, you're going to have your gravity going straight down, because it always goes straight down. And then because it's on an incline, your normal force is going to be going perpendicular to the ground. So it's going to be going at another angle, straight up from the car. When drawing the components, you just simply have to break it into f of g of x and f of g of y. So your f of g of x is going to be going to the right and straight down, or you could draw it in the opposite direction, but for this problem we chose to draw it down to the right. So it's going to be going in a positive direction, and then your f of g of y is going to be going back toward the vector at a negative. So you're going to have a negative f of g of y and a positive f of g of x.
So the next thing we had to do was plug in our variables into the f equals ma equation. So on the y-axis we have f of n minus fgy equals may, and since the acceleration is 0, we see that f of n equals fgy. Then on the x-axis, the acceleration is also 0, so we find that f of f equals negative fgx. Then we find that fgx equals fg sine theta using the coordinates on the graph before, and that's equal to mg sine theta because force of gravity is equal to m times g. Then we substitute in that into the force of friction, so we get the force of friction equals negative mg sine theta. Then we use our mu and we solve for the angle that the car can be parked on. So we know that the mu is the force of friction over f of n. We plug that equation to solve for the angle, and we get the mu times mg cosine theta, which is the normal force, or fgy, equals mg sine theta, which is the friction force. And we cross out the m because it's on both sides, the mg because it's on both sides, and we're left with sine of theta over cosine theta equals 0.8, and then we do an inverse tan of 0.8 and we get 36.66 as our answer.